My name is Gerald Alvarez. I'm an electrical engineering student here at Texas State University, and today I'll be explaining Ohm's law to you. This is a project for our Circuit 2 class, and the mission of this project is to explain a formula in electrical engineering so that someone from a different major, different background, a different field, basically simplify it and show a way and correlation that we use this on a day-to-day basis. Electrical engineering is very interesting. I think that it correlates a lot with the things that we do on a day-to-day basis. It's around us everywhere. So I just want to go ahead and sketch it out for you and basically use this formula in order to explain to y'all. So I basically drew a sketch here of a circuit, but we're going to start here in this triangle. In this triangle, we're going to have on the top voltage, and on the bottom our amps, and then our resistors, which is going to be our ohms. That's what the R stands for. So a resistor can be a light bulb, it can be a switch, it's something that's powered by the electric current. And our amps is going to be what's going through these. It's the electrons going through a circuit, basically through the wire, and our voltage is a pressure that's pushing these electrons. So in order to basically measure for y'all, I want to go ahead and do a circuit for y'all. It's a very basic circuit. Here we have our source of energy, our source of power, which is for, in order to keep it convenient, I drew just a simple battery. But let's say that we need the voltage of the battery. We don't know how many volts are in this battery. And we have a resistor here. Let's say it's a light bulb. So in this light bulb, there's 5 ohms. And let's say that we put a multimeter. We have our 2 tips touching both ends of the circuit of this wire, and it's 4 amps. We get 4 amps out of this wire, and we have 5 ohms. So in order to find the voltage of this battery, what we're going to do is we're going to come back to this formula over here. And so right now, when we have our amps, which I went ahead and illustrated for you, we're going to put it right here, which is our 4. Well, it's not very on there, but we have 4 right there, and our resistor is 5. So that's the light bulb, that's our amps. And then so we need to find our voltage, which is how many volts are in this battery. So from there, it's just simple multiplication. It's 4 times 5, and in here we would have 20. So once again, it's amps times ohms, 4 amps times 5 ohms, and it'll give us 20 volts. So let's say that we want to go ahead and find how many ohms we have in this light bulb. So we have, let's say that once again we touch tips with this, and it's amps. Let's say we have 2 amps, and we have a source of 8 volts. It's a little bigger battery now. So once again, our voltage is going to be on top. So we're going to have 8 over here, and we're going to have our amps, which is 2. So 8 divided by 2 equals 4. So that would give us 4 ohms here. And once again, it's the same with the other way. So if you just want to go ahead, and you can also work with this, you can double the voltage. So let's say that we have 16 volts this time. We're going to have a little more pressure, a little more current here on this one. We need to power something stronger, I guess. So you can also correlate it. I guess with this one, you can power 2 light bulbs now, or you can power this one a lot more. So it's not as dim. So let's say once we double the voltage, we're going to double the current, which means we can power bigger things. So you can power, let's say you want to like a Tesla, or they take a big big foundation, a big fountain of power in order to power those cars. So they have a lot more voltage than just your average house battery or anything that you may use on a day-to-day basis. But basically, that's Ohm's law. It's basically just using different factors such as amps or resistors to find volts, or finding amps with volts and resistors. It's all interchangeable. So once again, I hope this was a very brief explanation. I hope that I did my best in order to explain to y'all. This concludes my Ohm's law